Last but not least, well, actually, we got two more to go. We want to look at this problem where we want to solve is when does 2 cotangent squared 2t and 3 cosecant 2t equals 0. So this is going to be kind of a combination of two of the concepts we were looking at in this example. First of all, the only way I can solve it is if both of the functions themselves are the same kind. And kind of what you saw before is the only time I can get them to be the same is obviously I can only replace the one that's squared. So our identity says the cosine squared t plus 1 is cosecant squared t. Or replacing cotangent squared t with cosecant squared t minus 1. Okay, so start there. 2 times cosecant squared t minus 1. And looky here, I'm so used to writing my angle as just t's, but really what my angle should be is 2t, because that's what it was up here, was a 2t. So I got to make sure I keep that straight. And 3 cosecant 2t equals 0. All right, multiplying this out, 2 cosecant squared 2t minus 2 plus 3 cosecant 2t equals 0. Just rearranging this so that way I can eventually factor, because we do have a quadratic involved here. Okay, so what's in the front will be a 2 cosecant 2t and then a cosecant 2t. And then we want some factors of 2. It looks like if I put a 2 back here and the 1 right there, the outsides will give me a 4. I want that a positive 4 and then a minus 1. 2 cosecant 2t minus 1 equals 0. And cosecant 2t plus 2 equals 0. This first one is going to give me answers looking at, for 2 rotations, when are my ratio, like my sine values, equal to a half, and for 2 rotations, when are they negative 2. Unlike before, I want to be able to do all this basically in terms of sines and cosines. Well, cosecant, the reciprocal of cosecant is sine. So if I'm going to take the reciprocal of the left side, let's take the reciprocal of the right side, the reciprocal of the left side, and the reciprocal of the right side. Well, right here I can actually throw one of these answers out. I can throw out this first one that's saying when are my y values equal to 2 for 2 rotations. And if you look at that unit circle, the whole thing with the unit circle is the fact of unit meaning the radius is 1. So as I go around that circle, the farthest out I ever get is 1. So is there really any way that I'm going to be able to get a y value equal to 2? Not so much. So truthfully, all I have to look at is this little guy right there of saying when are my y values equal to a half, and then specifically negative 1/2, and then we're done. So those y values are negative in quadrants 3 and quadrants 4, and that part telling me we're going to go for 2 rotations. Okay, so 2t equals, so when are my y values, and we're going to go radians this time. So when are my y values going to be a half? Well, those look like they're going to be at pi over 6s, or multiples of pi over 6. In quadrant 3, that's going to be 7 pi over 6 and 11 pi over 6. There's one rotation. To get the other two, kind of like what I did before, all you're going to do is find the coterminals. So let's add on 2 pi and add on 2 pi. Coming down here for some side works just so I don't jump ahead of you guys and go, what did you just do? If I take 7 pi over 6 and I add on 2 pi, that's 7 pi over 6 plus 12 pi over 6. So it's really a 19 pi over 6. And then 11 pi plus 2 pi was technically adding on 12. So 11 and 12 is 23 pi over 6. Okay? So after that, then we just want to get our answer just in terms of t equals, not 2t equals. So if I divide off by 2, in a fraction, dividing by a whole number, all it does is multiply to your denominators. So you're really looking at 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. Box that up and call that answer finished. Alright, and our last one for this lesson. We have a sine squared 3t, a sine 3t. Everything there is in terms of the correct signage, so we're good there. We don't have to worry about the same trig function. We don't have to worry about replacing anything with an identity. And we want to give our answers in terms of radians. It looks like my angles are 3t's and 3t's, so I want to go for 3 revolutions eventually with this. So it looks like this problem is ready to get started, and we have to factor. And it looks like what's going to throw a kink in this is that negative square root of 3 right there. But this is where I'm going to help you out with. So I have 2 sine 3t. We don't have a choice. This is definitely what has to lead both parentheses, right? A 2 sine 3t and a sine 3t. That way when we multiply the fronts together, we get our 2 sine squared 3t. Okay, what has to go here in the back, obviously, are 2 numbers that we can multiply together to get 3. Let me tell you, what happens if you multiply the square root of 3 times the square root of 3? Well, it's the square root of 9, which is 3. Well, look there. I want to put I eventually want to multiply 2 numbers together that give me a 3 for the back. And what I have to add up to is the square root of 3. So what I'm going to do here is write it down as a 3 and a 3, a square root of 3 and a square root of 3. Okay? And then all we have to decide is which one's positive and which one's negative. Overall sign needs to be negative, so I need that right there minus, and this right here positive. Okay, so let's come over here and check all this out. Let's multiply this together and just real quick, take 2 seconds, and let's make sure that we actually get our polynomial back. So front to front would be 2 sine squared 3t. Outsides would be a negative 2 square roots of 3 sine 3t. Insides would be a positive square root of 3 sine 3t. And the backs is a positive negative, so it's a negative. Square root of 3 times the square root of 3 is 3. That one checks off, that checks off. If you have a negative 2 square roots of 3 and you add on 1, you only have a negative 1 square roots of 3. So it looks like those things check out and give us our middle term. Okay, so just finishing this up, we've got your product equal to 0. So you have 2 sine 3t plus the square root of 3 equals 0. And you have sine of 3t minus the square root of 3 equal to 0. Moving that square root of 3 over and then eventually dividing by 2, you'll have sine of 3t is equal to the square root of 3 over 2. And you'll have the sine of 3t is equal to the positive square root of 3. Alright, let's analyze these just for a little bit. And remember, we never ever can just divide off that 3. That 3, any number associated with your angle has to stay there. It's all telling you how far your rotations are. So never divide them off or add or subtract or try to do any kind of substitution. They have to stay there. Alright, I'm going to take 2 seconds and just look. It's saying when are my y values equal to the square root of 3 over 2? And the square root of 3 over 2 is roughly, what, 1.7 divided by 2? 1.7 divided by 2 is definitely less than 1, so that should be good. It's also something we should recognize as part of the unit circle. And the square root of the sine, when does our y values equal the square root of 3? And again, if you pull out your calculator, the square root of 3 is roughly 1.7. And just like in that last example, the unit circle only works for values that extend out to 1 and negative 1. This is outside of our realm, so we don't even have to worry about getting that for an answer. We only have to focus on this first one. So when are the y values equal to the square root of 3 over 2? And specifically, when are they positive? So we're looking at answers in quadrants 1 and quadrant 2. And for 3 full revolutions. It says in radians, so square root of 3 over 2 for the first time for a y value is going to be at pi over 3. And in quadrant 2, it would be 2 pi over 3. Okay, so every time I'm going to take one of my values and I'm going to add on 2 pi, or like pi over 3 plus 6 pi over 3. I'm going to add on, why I wrote 6 on the bottom again, I don't know, but we're going to be adding on 6 pi over 3 every single time. So 1 pi plus 6 pi over 3 is going to give me 7 pi over 3. 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. And there's my second rotation. So now I'm going to start with the 7 pi over 3. It's getting kind of sloppy today. 7 pi over 3, and let's add on 6 more. So you have 13 pi over 3, and then 8 plus 6 is 14 pi over 3. And that wraps up my third revolution. Let's divide everything through by 3, and you'll get t to be, instead of pi's over 3's, it looks like we now have pi over 9's. So running through this just real quick and writing them all as just pi over 9's, and we can call this problem done after this. Box it up. We're finished.